So for instance, when you are given, this is a continuation of the class. So we are talking about Ka and for instance, when you are given two, what do you call it, two compounds. And they give you the Ks of this compound. They tell that the K of this is 1.7 times 10 to the power minus 5 mole per dm cube. Then you are also given another one. Also given another one. I'm giving this one. And when you are giving something like this, and so the K of this is this. What's the name of this? Who can tell me the name of this? This compound and this. Who can tell me the name of this compound? Who can tell me?
For the first one, I know it's ethanoic acid.
Okay, correct. And the second one?
That
Maureen, what's the name of the second one?
So please no.
You have no idea. Adakwatina. Maureen, you said it's what? Your network, I can't hear you.
So please, I said no idea.
No idea. Okay. Adakwa Yaram. Your name is so sweet.
I don't know.
Okay, so the name of the first one is ethanoic. It comes from the carboxylic acid there. So they are all acids. So this is ethanoic and this methanoic. Methanoic acid. And so Ruben, take note. So when you're given the Ks of this, and you're asked to find which one will have, what do you call it? Which one is a strong acid and which one is a weak acid? Will you be able to tell? Or which one is stronger than the other, or which one is weaker than the other? Can you be able to tell me? Which one is stronger than the other?
Yes.
Okay, talk to me. Talk to me. So you know that the Ka value of the methanoic acid, which is the HCCOH, is greater than the Ka value of the methanoic ethanoic acid. How we've seen that. Therefore, it is assumed that because the methanoic acid is greater than that of the ethanoic acid, therefore the CH3COH is a weaker, less dissociated acid than methanoic acid. Are you getting it? Are you getting it?
Yes.
Who else? So this one, this I've already explained, is a weaker or less dissociated acid than methanoic acid. And so you can tell. So that one, this one dissociates lesser than that of this one. So that's what it means. Now, so there are some instances they can give you the pK values of benzoic acid, ethanoic acid, and methanoic acid. Then they give the pH. Then they tell you that arrange the free acid in increasing order of acidic strength. So then you are giving the pK values, and you know when you talk of the pK values, basically we are talking about the pH of the dissociation constants, and I've already explained how it works. So the values you can be able to do, you can be asked to arrange it in terms of increasing order of acidic strength, and so you should be able to do it. And they can also tell you that explain your answer. So that's why you are going to use the higher the distance, the lower the distance, as I've already explained. Now let's solve some 1 or 2 questions under this. A weak acid, HA. He said HA will stand for a weak acid. A weak acid HA has dissociation constant Ka. It has dissociation constant Ka to be equal to 1.8 times 10 raised to the power 5. 10 raised to the power 5. Calculate the pH of 0.10. Calculate the pH of 0.10 molar. Molar of the aqueous solution of the acid. Aqueous solution of the acid. Can we try our hands on it? So the question states that a weak acid, which is HA, has a dissociation constant. In other words, an ionization constant, acid ionization constant, to be equal to 1.8 times 10 raised to the power 5, and it has a pH of 0.1 molar. So the 0.1 molar is the concentration of the weak acid, aqueous solution of the acid. And the question states that we should find for. The question says that we should calculate the pH of the 0.10 molar aqueous solution of the acid. And so that means you have to find for the pH of the aqueous solution. And so what are you going to do? We first know that our Ka is equal to, given this, our K is equal to what? That will be equal to our H free, concentration of our H free, and our A divided by our let's say our HA. I hope you know where we derive this equation from. Hello, I hope you know where we derive this equation from. Well, here we are. The water is going to be negligible.
Yes, sir.
It's going to be negligible. So you bear with me that if you have to draw the full chemical equation, you realize that they are equimolar. When you say they are equimolar, their moles are 1. It's 1:1. I don't know if you get what I'm trying to say. When I wrote the full equation, then it will be HA plus H2 is equal to H3 0 plus HA minus. And you realize that H3 0 and the A minus, they are all equimolar. When we say they are all equimolar, they are of the same molarity. Let me put it that way. So as a result, we can equate them and make it 1. Do you get it? And so we can get Ka is equal to, since H3O and A they are equimolar, then we can say that they are of the same molarity. We can say that they are equal. So this will be raised to the power 2. Raised to the power 2, and still divided by our H plus. Still divided by HA. But let's not forget that we've been given Ka. We've been given Ka to be 1.8, right? 1.8 times 1.8 times 10 to the power 10 to the power 5 is equal to we don't know that of A3O. We don't know the concentration of A3O. But we've been given that of the aqueous solution, which is the acid solution to be 0.10 m. And so we are going to get H3 squared all over the concentration of HA. HA we are given to be 0.01. 0.10, sorry. So given this, we want to find for the concentration of H3O. And so what we are going to do is we can multiply this by this. We can multiply this by this. I hope it's correct. So we can have H3O squared. H3O squared should be equal to 1.8 times 10 to the power 5 times 0.10. What are you getting? What are you getting? Sorry, it's raised to the power minus 5.
16,000.
It's raised to the power minus 5. Sorry. So I'm going to get. Let's raise the power minus 5.
18,000.
I said it's raised to the power minus 5. So we'll do the calculations well. So I'm going to get 1.8 times 10 power minus 6, right? And so if you want to find for each the concentration of the concentration of the water we find or we get after the product, let me put it that way, the product, the concentration of this, we have to root this one. And so the square root of this, what are we getting? The square root of this, what are you getting? H3 is equal to the square root of 1.8 times 10 to the power this. What are you getting, please?
1.34 2 times 10 exponent negative 3
times 10 exponent negative 3 exponent minus 3. So so this becomes the concentration of what do you call it, the H3O, the H3O what do you call it, solution. So this becomes the concentration. Now the question is saying that calculate the pH of the distance. So we've been able to, that's what we are getting. Now we have to calculate for the pH of this. So given this, how do we calculate for the pH of this? What are you going to do? This is the aqueous. When I say aqueous, the solid, the water part. Are you getting what I'm trying to say? And so this is the water part of the solution. And so what are you going to get? We've been given the acidic part, and after.
So sir, doesn't it have a unit?
It has a unit, please. It has a unit. It will take the unit of what they call it, a concentration. You know the unit of a concentration, or don't you know the unit of a concentration?
Yes. Sir.
But in this case, this one, I'm coming. This one should have a unit. This is this thing. If it was to be only this, then it wouldn't have a unit because the units will cancel because you bear with me that they are all concentration. But this one will have a unit. So this one, the unit of this will be mole per dmq because this we are talking about what the concentration here. I hope you getting it.
Yes, sir.
And so having gotten the concentration of this, and now we can find for the pH of the aqueous solution. So the pH of the aqueous solution will be equal to minus logarithm, right? Minus log of this. And so what's the minus log of this answer? Please use a. I'm coming 3/4 times 10. This is the power 3. Please, what are you getting?
2.872.
So pH is equal to 2. 2.87. So this becomes our pH. Then it means that the solution is acidic. It has proven that the solution is acidic. And in this case, we can say this is a strong acid. Are you getting it?
Yes, sir.
Because it's 2.87. So that is, so when we are given a question like this, the weak acid, there's a weak acid. Now you bear in mind that when you have the weak acid coming together with water, here we are talking about ionization. So definitely there should be the presence of water. And that will give you your aqueous solution, which is the H3 O plus your A minus, which is some of the ions of the distance. But you bear with me that the two, they are equimolar, so we can say that they are equal. So we just have to multiply them and raise the power 2. And so that is it. So you come and find the concentration of this. This means that the concentration of this is the same as that of the H minus. That's what it means. That's what it means. So this is the entirety of the concentration of this. Now, when we come and find the distance, we are going to get to this one. When we come and find the root of this, then we are going to get this. And so that means H3O is equivalent. The concentration of H3O is equivalent is this, and that of H minus, that of this H minus is also equal to this. I hope you are getting it because they are equimolar. So it's also equal to this. And so pH is equal to minus log into bracket 1.34 times 10 to the power minus 3. And we can be able to get this. Now, in other words, or in other ways, we could have gone straight. Looking at this calculation, we can derive a simple formula for it. So now we can say that our concentration, the concentration of our H3O plus. Let's always forget that there's a plus at the top. H3O plus. We could have just as well use this equation. Let me. So this can be equal to root of Ka C. KAC. So we could have just used this to find for that of this. So let's factor it into it. So instead of going through the whole of this thing, you know that we've been given the concentration of the aqueous solution to be 0.10. So this will be the concentration. And we're given that of Ka. That of Ka in the question we're given to be, is it this one? Yes. To be this. So we can, to be this. So we can factor this one to an equation. Then we can just go straight ahead and get a concentration of H3O. Are you getting it? That makes it very simple. So this is the concentration.
So HA is equal to concentration.
Is that? Please
So
come
say
again.
KA is equal to HA is equal to concentration.
HA is the HA is a weak acid. We are talking about the weak acid or the acid. In other words, HA is the acid.
Concentration or no concentration?
Concentration of the acid. But before you can say something is concentration, the HA itself is the acid. HA is the acid. Now, when you put it into brackets like this, then we call it the concentration of the acid is equal to, then you can get your answer. So you realize that it's in brackets. That's why I'm saying that this is in brackets. So I can say the concentration of the aqueous solution is equal to the root of the Ka, which is the acid, the dissociation constant of the acid, times the concentration of the HA. Are you getting it? Well, here the question emphatically said that.
Yes, sir.
The question emphatically gave you the concentration of this one, 0.1 aqueous solution of the acid. So 0.10 m aqueous solution of the acid is the HA. Are you getting it?
Yes, sir.
Exactly. That's what I wanted to do. Any more questions? So after getting this, then we can come and find the negative logarithm of the answer. Then we can get our pH to be this. So even with this, straight ahead too, we can also see that, okay, looking at this, we can just write, you can also go forward and say our pH is equal to the minus logarithm minus log of, what do you call it, the H3O. You can get something like this, and that's to make it very simple. And we can just further do the calculations and come and get. Well, we know that the H3O, the concentration of the H3O is given by this, so we can factor this one here. This mathematics, so we can get pH is equal to minus log of K2 K3O raised to the power half. I know you know where we got the half from. I believe you know where we had the half from. The half is this, please, is this. So now further mathematics, so we can get pH. The pH can be equal to when it is log, then that means we can bring this one here. I hope you know that. So we can get minus, oh, here was supposed to be KAC, sorry. Here was supposed to be KAC. So here we can get minus half log KAC. But let's not forget that the Ka is multiplying the C. And in log, when they are multiplying, that means we add. So we can get our pH to be equal to, and the minus half is multiplying the whole of them, or they are all affected by the minus half. So what is going to be is we are going to get minus half, log K, log Ka plus log C plus log C. This is what we are going to get. And when we finish, we can see that minus is multiplying through, so we are going to get, you can however get pH is equal to half log Ka minus log C minus log C. So this can be our final answer. So let me boldly write it here. So we can see that our pH can be written as half log Ka minus half log C. Please, this one is half, there's half here. So that is it. So looking at the expression or looking at how we did the calc, I hope you can all hear me. Maureen, how are you? No. Ruben, can you hear me?
Yes, sir.
So looking at how we calculated it, we can however derive a formula from how we calculated it to be very simple like this. So when we are given a question and the question states that we should find for pH, given the C, there's log and there should be supposed to be G here. Given the C and given the Ka, then we could just, instead of going through the whole of this process, we could just write this formula and just we are good to go. Are we getting it?
Yes, sir.
We could just listen. Or in other words, we can also start from here. Then when we finish, we come and find the negative log of the answer we get here, and we are good to go, whichever way. So we can just start from here. If you like, we can start from here. After finding for the answer, then we come and find the negative log of the answer. That will give us our pH. Are we there? And any of them should give us our answer. Any of them should give us our answer. Now, let's do that of the base. Bridget, how are you? If you have any question, ask. Ruben, check the time for me. How many minutes more are we left with? Ruben.
Sir, please, I'm checking.
Okay, check for me. We have 10 minutes more.
Sir, 32 minutes go.
Okay, we have 10 minutes more. So, that is it. Now, with the, I think the network is disturbing some people, but when we finish, they'll enjoy it. So let's do that. I wanted us to solve one more question, but I want us to also finish that of the base before we can solve some other questions. So the base also use the same format. But the base, because it's base, we are saying instead of the K, we will name it KD and pKb. pKb. That is it. Now, a weak base ionizes slightly to give few hydroxide ions. So when we are talking of base, we are talking about hydroxide ions. That's making a solution alkaline and a weak electrolyte. Aqueous ammonia is an example that dissociates as follows. So now let's consider aqueous ammonia, which is a weak base or something. So NH, you know ammonia is NH, eh? NH, aqueous ammonia, NH3 is a weak base too. So plus H2O, just as we did for the first one, it's the same thing I'm going to do. Plus H2O should give us the H. Next one, you are going to get H plus. So we are going to get the HR2. So we are going to get NH4 plus H plus OH minus. This already we know. So if you have to find for the KB, you bear with me, and the KB will become what? Will become the NH what do you call it? NH4 into bracket OH minus all over. Then we are going to get the distance all over. You neglect the water, so all over NH3. In this case, this will be the aqueous solution of the base. So that's what we are going to get. And so the same calculation like we did for the acid is the same thing. Like it's the same thing. The same thing. So basically, it's the same calculation you're going to do. If you are to find for the pKb, if you are finding for the pKb, it's also equal to the negative logarithm. Negative log.
So say please, what is the ion? You have not given us whether the NH4 is plus or minus.
The NH4, I said the NH4 is plus. This one is minus. You know that OH is always minus. And this one, if this one is minus, this one become plus.
Okay.
I get it. So OH minus and this one OH plus. Oh, Maureen is having an issue with her network. I think she connects and it goes off. And the KB for what do you call it? This at constant temperature of 29 K is 1.7 times 10 to the power minus 5 mole per dm cube. So that is it. So it's the same principle. The higher the KB and the lower the pKb, the stronger and more dissociated the bases. So it's the same thing like we did for the acid, just the transfer of knowledge. Now let's solve one question. For one, I'm nearly say 1 million. For one M, we are doing this 1 M solution of ammonia. Calculate the pKb. For 1 M solution of ammonia, calculate the pKb. So you have to calculate for the pKb. And number 2, calculate the hydroxide ion concentration. So you have to calculate for the hydroxide ion concentration. So given that we are given a pKb is equal to, the question is the pKb is equal to 1.74 times 10 raised to the power times 10 raised to the power -5 mole per dm cube. So let me read the question again. For 1 molar solution of ammonia, calculate I, the pKb, II, the hydroxide ion concentration, given that Kb is equal to 1.74 times 10 raised to the power -5 mole dm minus cube, or mole per dm cube. And the Kb is the base dissociation constant. So that is it. How do we solve it? Ruben, how do we solve this? We are going to use the same principle. The first question says that did you find for pKb? And finding for pKb, we've already been given Kb to be this. So pKb will be the negative log, right? With the negative.
Yes, sir.
With the negative log of the 1.74 times times 10 raised to the power -5. What are you getting, Ruben? When you use this in log, what are you getting?
4.7594.
4.7594. Okay, so this one will become our pKb. Now, the question 2 states that we should find for. The question 2 states that we should find for the hydrogen ion concentration. The hydrogen ion concentration. Let me see. Sorry, hydroxide ion concentration. Hydroxide ion concentration. And so it's simply the same thing. So we know that Kp is equal to what do you call it? The NH4OH, and we are looking for this OH. By looking at the equation, you realize that this and this they are equimolar. Are you getting it?
Yes, sir.
Just as we did for the acid. So we can say, because we are looking for the OH, we can say OH raised to the power 2. OH raised to the power 2 divided by, we've been given the concentration of this NH3, which we are given to be 1 mole, right? 1 molar, sorry. So all over 1. And we know the Kb2. We are given the answer of the Kb. So we are going to multiply the 1 by the Kb then we find the root of it. So in simple terms, the concentration OH OH should be equal to OH should be equal to the root of what? Should be equal to the root of pKb C. Sorry, the root of KBC, like we did for the other one.
Yes, sir.
You get it? So it should be equal to.
Yes, sir.
So the answer should be equal to the root of KBC. Well, we know that our C is 1, our KB is 1.74 times 10 to the power minus 5 times 1 all root. So what are you getting? OH, what are you getting OH to be?
So is it 4.17 times 10 raised to the power -3?
So we are getting 4.1 4.1.17, right? 7 times 10 to the power what?
-3.
Like -3 mole per dm. So that's what we are going to get. So it's the same principle we use for the acid. It's the same principle we are going to apply in the base, because basically we are using the equilibrium rule or something. I hope you are getting it. We have less than 1 minute. I'll upload it on YouTube so that you go through, then we see what tomorrow we have commas, but tomorrow is a holiday, but we will learn. We have commas tomorrow, God willing. Or I should give it to you as